Okay guys, in this video we're going to learn how to count electrons based on the situation given in chapter 2. So this is a typical problem in chapter 2 atomic structure for matriculation level. Usually they're going to give you the information about a species. So over here we have magnesium, and then the question will ask you how many electrons with the quantum number m equals 0. So to do this, the first thing you need to do now is to look for the atomic number or proton number for magnesium. We can do that by looking at the constant values R, A, M given to you in exams. Here we can see that magnesium Mg, the atomic number, or another term for this one, proton number, is 12. Okay, so the proton number, we have 12. So when the proton number is 12, then we know that the number of electrons will also equal to 12. So when we know the number of electrons is 12, we should be able to write down the electronic configuration for this particular species, which is magnesium. So the first thing you need to do is to write the electronic configuration. We will have 1s2, 2s2, 2p6, that is 10, 6, 7, 8, 9, 10, but we have 12 over here, and the next one would be 3s2. So this is the Spdf notation, and note that the question wants you to find out electrons with m equals to 0. So when you look at the Spdf notation, the information is not that clear yet. So what you need to do from the electronic configuration of Spdf here, you're going to change that into orbital diagram. Okay, so we have 1s, 2s, 2p, and 3s. And of course, you're going to have 2 electrons. Okay, you have 2 electrons over here, and you have another one right there. And you have 6 electrons over here. Just going to fill that in. So 1, 2, 3, 4, 5, and 6. And then we have 2 electrons in 3s. We have 1 and 2. Do remember that this is the quantum number for n. Okay, so those are the quantum number for n. And then s over here and p, those are the angular momentum quantum number, which gonna tell you the shapes of the orbital. Okay, and do remember as well, when you have L equals to S, the value over here will be 0. This one is also 0. Over here you have the value of 1, and here we have value of 0 as well, because the shape is S, so L value is 0. Okay, and we have talked about this before. The value of L will determine the value of M. So the value of M over here would be 0. This one will also going to be 0. Same goes to this. And for that one, the value of M, you will have 3. You have -1, 0, and +1. So you can say that in the s orbital over here with m equals to 0, you have 2 electrons. So you have 2 electrons with m equals to 0 right there. And then you have another 2 electrons with m equals to 0 right here. And then you have another 2 electrons with m equals to 0 right there. Whereas for these orbitals, you can say that for your level at least, you can say that this is -1, this is 0, and that is +1. Therefore, that is another 2 electrons with m equals to 0. So 2 plus 2 plus 2 plus 2, you have 1, 2, 3, 4, 5, 6, 8 electrons. So the answer over here, okay, so the answer 8 electrons with m equals to 0 for magnesium. Now, we're going to do the same technique to solve problem number 2. This time, the question asks you to do something else, okay? So instead of finding m equals to 0, you need to find s equals to plus half. Again, you're going to start with this, supposedly. So you're going to find out the proton number, and we have figured out that already. So the proton number is 12. If you want to double check that. Magnesium, you have 12 right here. So that is 12. Therefore, the electrons number, you have 12 as well. And we have the Spdf notation 1s2, 2s2, 2p6, 3s2. Okay, and then you have 1s, 2s, 2p, 3s, just like what we have done just now. Okay, I'll just speed that up. And do remember, you can assume that you can say that the electrons or the arrow going up, those are representing the half, positive half, and the arrow spin going down here representing the negative half. So you can say that those in green here, I've circled in green, those you can say that these are the positive half spin, and those in yellow, those spins are, we can say that it's going to be negative half. So when you count the green ones, you have 1, 2, 3, 4, 5, 6. Therefore, the answer is 1, 2, 3, 4, 5, 6. So you have 6 electrons with spin half. Okay? Now, let's have a look at another situation. This time you have 2 things you need to consider. Just now in problem number 1 and problem number 2, you only need to consider one situation or one quantum number. But for problem number 3, as you can see here, you need to find out how many electrons with n equals to 2 and s equals to -1. Again, we're going to start by looking at the atomic number or proton number. We've known that already from problem number 1 and problem number 2. The proton number for magnesium is 12. Therefore, the electron number would be 12 as well, because here you do not have any charge, okay? We're going to start with the Spdf notation. 1s2, 2s2, 2p6, 3s2. Or you want to sing that out. 1s2, 2s2, 2p6, and 3s2. So it's really up to you. If you want to do that kind of technique, so remember, it's up to you. Just have fun with it. Now, you've got this SPDF notation. And just now I said to you that it's better for you to write that in orbital diagram as well. So this is the orbital diagram. So you have that. And make sure your arrow are fully headed arrow for the spin of electrons. Okay. Now, the requirement that we need to consider, okay, the requirement that we need to consider is n equals to 2, s equals to negative half. So when n equals to 2, remember these numbers over here, the one I have double line in red, those are the n. So automatically, you do not have to look at this because that is n equals to 1. And you don't have to look at this because that is n equals to 3. Because we need to look at n equals to 2. You have 2 n equals to 2 right here. And you need to consider s equals to negative half. Do you remember just now I've told you these are considered as the plus half spin, or the spin that is going to be clockwise. And we have those here. Okay, so that is negative half spin. So how many of that? So we have 1, 2, 3, and 4. Okay, n equals to 2. Okay, n equals to 0 right here. And s equals to negative half. So negative half, negative half. And therefore, the answer is 1, 2, 3, 4. 4 electrons. If you want to write this down, it's okay with n equals to 2 and s equals to negative half. Now we're going to look at iron. We have looked at 3 examples for magnesium. What about iron? We're going to do something else right now. So we have to check what is the proton number for iron. We look at this table right there. Iron, the proton number is 26. Okay, you have 26, and therefore you have 26 electrons you need to consider. So what is the electronic configuration? So electronic configuration, 1s2, 2s2, 2p6, and that will be 10. And then 3s2, 3p6, and you have 4s2, that is 20, yeah? You have 6, 7, 8, 9, 10. 6, 7, 8, 9, 10. Now you have gone into the 4s2, and this time you're gonna start filling in the 3d6. But now you have started to fill in 3d. Therefore, you need to rewrite this. Okay, you need to rewrite this whole thing because now you have started to fill in 3D. So you're going to write that again. 1s2, 2s2, 2p6, 3s2, 3p6, 3d6, 4s2. So that's how you're going to write it. In reality, when you start to fill in electrons in your 3D orbitals, the energy for that one of that orbital will become slightly lesser than for s, and that's why the 3D will go to a lower energy level and 4s will go up to a much higher energy level, because 4s filled 4s over here is going to be more central symmetry. But that is quite, it's too complicated for you to understand for your level. It's enough for you to know that once you start to fill in the 3D orbitals, even with one electrons, that's when you're going to shift this. This one is going to go here, and that one will be shift place only for 4s and 3D. Remember that carefully, guys. Now, let's have a look at the electronic configuration. Do we get it right? 1 is 2, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 20, 26. We have 26. That should be okay. But what do we need to find out? You need to look at what the question wants. M negative 1, S negative half. So remember, M negative 1. So who will be having M negative 1 here, guys? We do know that if we're gonna change this, okay, I'm gonna change that to orbital diagram. We're gonna have 1s, 2s, 2p, 3s, 3p, 1, 2, 3, 4, 5, 3d, and you have 4s. So you have all of this electrons. Okay, just be very patient and careful about it. So you have 1, 2, 3, 4, 5, and 6. 1 and 2. Okay. Do you still remember all the red one here that I have double underlined? Those are your N. And then the lattice, those are the one in green. These are your angular momentum quantum number. And do remember that the M value will depend on here. When your L is, okay, we do know that this L equals to 0. This one is 0. This one is 1. That one is 0. This one is 1. This one is 2. This one is 0. So when L equals to 0, then we know that M equals to 0. This one M equals to 0 as well. This one is M equals to 0. This one M equals to 0 as well. So when M equals to 0, automatically you do not have M equals to negative 1. So these orbitals, S orbitals, will be dismissed. Okay, you don't have to look at that one. And when you look at this, okay, when you look at this one, we do know that the M over here will be negative 1, 0, and plus 1. Same goes to here. You have negative 1, 0, and plus 1. This one will be even longer. 1, 0, plus 1, plus 2. So you can imagine that, like what I have told just now, that you can imagine that this one will be negative 1 subshell. This one is 0. This is plus 1. For P, negative 1, 0, plus 1, negative 2. This one is negative 1, 0, plus 1, plus 2. We need to find for negative 1. So these are the negative 1 electrons, 1, 2, 3, 4, and 5. Okay, so let's identify that one first. I am going to use blue, so that are the electrons we want to focus at, because we need to find for m equals to -1. But do remember, we need to look for positive half spin. And you do know that in here you have positive half and negative half, positive half, negative half, and positive half. Therefore, you have one electron, another one electron, and over here another one electron. So 1 plus 1 plus 1, you have 3 electrons. Therefore, the answer is 3 electrons. So you need to fulfill all what does the question want. So you need to fulfill those. In this particular case, you want to fulfill m equals to -1, s equals to positive half. So you have m equals to -1 here, 1, 2, and 3. But inside here you have positive and negative. All right, so you need to take that into account. Now, what about copper? How many electrons with this time n equals to 4, L equals to -1? Copper, the proton number for copper here is 29. Okay, so you have 29. Therefore, the electron number will be 29. So if you do the Spdf notation, 1s2, 2s2, 2p6, that is 10. 6, 7, 8, 9, 10. We need to have 29. So another 10 would be 3s2, 3p6, 4s2. That is 20. And now you're going to start filling in 3d9. And do you remember, I've told you this now, once you start filling in here, okay, you're going to start to shift. Okay, so you're going to have 1s2, 2s2, 2p6, 3s2, 3p6, 3d9, 4s2. But for copper, I'm going to explain to you about this one in the next video. For copper, what happened here, okay, what happened here will be quite interesting. So for copper, it will be, instead of 9, it will be 10. This one will be 1. This one is only for copper. This is the anomalous case. So we're going to look at in the next video, guys. All right, but that is not important now. What we need to look now is we need to find out what is the how many electrons with n equals to 4, L equals to -1. So n equals to 4, automatically we can say that we can ignore all of this because these are not n equals to 4. So this is n equals to 4. So you have L, which is equal to 0 over here, and therefore M will equal to 0. You won't have L equals to -1. So for this case, the answer is 0 electron. Okay, so that is the answer. So that's how you're going to do a question like this. It's quite fun to work it out from the Spdf notation and try to look at what information given to you, what does the question want, and you should be able to do your strategy to find out how many electrons.